Okay, hello students. This is the first example that I'd like you to watch in terms of videos. You'll note that the rest of the examples for this chapter I pulled off the internet because I found some really good stuff. So the rest of them are some other guys, a couple different people. And then chapter 2, I have a lot more detailed examples, and I think you'll probably rely on them more for chapter 2. But please, I do encourage you strongly to watch all of these examples. You're really going to need them since you're going to be on your own mainly this summer. So there's only a couple things out of chapter 1 that need more attention. The book does a pretty good job. So first, let's look at example 1.3 on page 10. You should always have your book open. It says 8,000 meter peaks. The 14 tallest peaks in the world are referred to as 8,000ers, meaning their summits are over 8,000 meters above sea level. And it says, what is the elevation in feet of an elevation of 8,000 meters? So we need to convert 8,000 meters into feet. I really like this problem because I've just been obsessed with those 8,000 meter peaks and reading about them lately. Anyway, okay, so we have done this in geometry before. If you had me, if it's the first time, that's no big deal. Um, I just don't like the way the book treats this, so I'd use these videos. Anyway, so we need 8,000 meters to feet. The thing is, we're only given this piece of information. They tell us that 1 inch equals 2.54 centimeters. Now, you're always going to be given some conversion factors like a table on your AP test and stuff. They're not going to have the most obvious things in there. So in the previous couple pages of the book, note that they had things like what is a kilo, what is a micro, what is a pico. You need to have all those conversions memorized. That's something pretty important, and we'll take a quiz on that at the beginning of the year. But things like this, I mean, there's no way you're going to know that. So you're also going to be given information on these types of things. You need to adjust. Anyway, the idea is 8,000 meters. We need to eventually get it into feet. So first I said, well, we kind of need to get to centimeters since we know this. So how many meters are in a centimeter? I put meters down here so that they cancel out. And what I want to get, I put up here, which is centimeters in this case. Then I say, okay, how do these relate to each other? Well, I think 1 meter is 100 centimeters. So you have to think for a second. That's one you should just know, like I said, from memorizing the table. Okay, then we say, okay, we don't want centimeters. So let's get rid of that and put it down here. But let's go to inches. And then that's the one that they gave us. They said 1 inch is 2.54 centimeters. So notice sometimes the number is on top, sometimes the number for the conversion is on bottom. Usually there's both things that happen. Anyway, so we weren't going to centimeters, or excuse me, we weren't going to inches, we were going to feet. So we say, okay, we want to get rid of inches, we want to get feet. Now, of course, we all know feet and inches, I hope, but you should all know this too. Ha. So 1 foot is 12 inches. Okay, and then we just multiply across, cancel stuff out. Meters go away, centimeters go away, inches go away, and we're left with feet, which is what we wanted. So we go multiply across the bottom, and do that little computation, and you get this. And that should be in feet. So an 8,000 meter peak is above 26,246 feet. There's no significant figures issues on this because they just said they considered all these zeros significant. So if you watch the significant figures video, they really should have put a decimal point right there. Okay, let's look at one more example I thought we should see. Okay, this is 1.5 from the book, and it has speeds. It says, take 55 miles per hour. Sometimes you'll see it like this. I'd write it like this when you're doing physics or chemistry. Convert it to meters per second, and then separately convert it to kilometers per hour. So same strategy, except I've got units on top and bottom here. So I want miles to be converted to meters first. So I say, okay, going to meters. We're given the same conversion from the previous problem. That's all we have to work with besides our memory. Okay, so we need to go miles to meters. So we say, I'll get rid of miles. Let me change that into feet. What's the conversion there? I think we should know that one. That's 1 mile is 5,280 feet. And we say we don't want feet. Let's change that to inches. So, 1 foot is 12 inches, right? See, on the previous problem it was upside down. I'm saying it could be either way. We don't want inches. We want to go to meters. So let's first go to centimeters because of that given thing they told us. They said that What did they say? What did they say? Did they say 12? Nope. I'm wrong. I think they said that 2.54 centimeters was 1 inch. Yeah, that's what they said. Anyway, then we say, okay, we don't want centimeters, we want meters. Oh, we go 100 centimeters, it's 1 meter. Then we say, okay, so that's going to go chop, 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 and we have meters left. But we wanted seconds. So far we have hours. So to get rid of this hours, I'm going to put hours on top so that they chop. And I'm going to change that to seconds. 1 hour is how many seconds? You might have to think for a second.
Students, we have a couple of bus changes for today. If you ride 69, you will ride bus 7 home. And if you ride 21, you will ride 234 home today. Thank you.
So as I was saying, 1 hour is how many seconds? Well, there are 60 seconds in a minute and 60 minutes in an hour. So this is like 60 squared. 60 times 60, which is 3,600. So then you say, okay, now we can get rid of those hours, and we have meters per second, which is what we wanted. So then you multiply across the bottom. Here you go, you get that. Now, my question mark is this. Why did I round that to 25 meters per second? Remember, significant figures. How many do we have to start with? 2. Can only use 2. So we look at those two things, look at the next digit, and round it up. Okay, now we're going to go to kilometers per hour. So we'll get rid of miles by putting that there, and I'm going to go straight to meters. We could go through all this work up here again, but just note from part A, 1 mile is this times this times this divided by 100, leaving out that seconds part. It's that many meters. So I can just say 1 mile is 1609 meters from the work I just did instead of writing it out and going crazy. But I wanted kilometers, so I'm going to say, okay, put the meters down there in kilometers. Then you say, okay, I know that 1 kilometer is 1,000 meters. And those cancel, and you get kilometers. And we're already in hours, so you just do that little guy, and you get 88. 88, right? Not 88.495 if you think about significant figures. Okay, I think that's all I'm going to do. There's one more conversion example that I posted, and really make sure you watch all those significant figures videos because I don't want that to be a stumbling block. We aren't going to have time to deal with worrying about that too much. We're going to go straight into two-dimensional motion when we start the first week of school. So I hope you find these videos useful. Adios.